I'm now gonna set up a couple of problems. I'm not actually gonna solve them. Reason being, right? You just find your APRNT or APRNT, uh, and plug it into the proper equations. Once you do that, right, it turns back into a Math 1 problem. Or because you have an equation, you can put it in Desmos and find the x value where your graphs intersect. Okay, so in 2005, 600 students at Farmville. Population has increased by 12% every year. How many students will there be in 10 years? So when I do these, again, figure out what we're trying to solve for. We're trying to figure out how many students there will be in 10 years, or the total amount of students. So this is what we're going to be solving for. Years, T is 10. And one piece of advice I can give you is, like, just the more of these you'll do, or the more of these you do, the better you'll be at identifying these particular parts and pieces. 2005, there were 600 students. So I start off with 600 students because that's when the survey or the data was started being collected. And then population has increased by percent. So your growth or decay is always going to be a percentage. And because it's 12%, we know this is a growth. And then I think about the following, right? N is also a potential variable. If I don't see the word continuous, then I don't use N. So nowhere in here does it say compounded continuous, or compound as well. So now I know I'm either using A equals P1 plus R to the T, or P1 minus R to the T. Increase is growth. Growth is we add. So I'm going to use that equation. And again, we're solving for A this time. Okay. I'll do this one right here. Number of subscribers to a new Twitch stream has increased 5% each month. So rate 5%, and then it's going to increase per month. So I know, again, it's growth. In the first month, they had 250 subscribers. So 250 the very first month. If the growth continues at this rate, how many subscribers after 2 years? Now, if your growth rate and time is in different units, so you need to convert them. I'm just going to go years to months because I don't have to divide. So 2 years is really 24 months. And again, we're solving for A again. Tomorrow we'll look at a handful of more examples and, use, again, a couple of different equations.